Hi, welcome to the first tutorial in this series with some catchy title. I don't know what the title is going to be. What did I pick? Who Wants to Be a Millionaire? That sounds pretty lame. Whatever it was, you chose to watch this because of my catchy title. And so, catchy millionaire. You're going to retirement simulator thing. Okay. Truth be told, this is not going to be super glamorous. However, the crux of the matter is that we're going to create a simulator that marches through time and predicts how much money you could save for retirement. So, again, not super sexy, but super helpful if you want to plan for retirement on your own using your own math and numbers. And so, none of this counts as advice. All of it is just showing you how to build a simulator that can march through time and multiply and add numbers together. Because that's just about how simple it is. But at the end, we should be able to make a customizable simulator that can predict how much money you might save for retirement given typical savings scenarios. So, with that said, I'll bring your attention over here and say that normally in this kind of thing, I would use a Windows terminal and I would use a notepad editor. I'm going to do this instead using the Spider editor, which I'm going to bring up right now. There it is. Excuse me. And if you don't have it, I would say go onto your favorite web browser and do a search for something, Spider Anaconda. There we go. And one of the first things that comes up should be this, spideride.org. If you go there, it brings you to a website. If you go to download, I don't know if this is true. It looks like it determines that I have Windows. You go here and you hit save file. Now I already did that and it took a long time. So then here's this thing, and you would open the file, and if you don't know how to install a program at this point, then you're done. See you later. Have fun. I'm not going to be opening that right now. I hope I didn't open it anyway. I did. Okay. No, I don't want to do that. So I already did it. All that said, I'm going to use the Spider IDE, Integrated Developer Environment. It has your scripting area over here. It has your Python console over here. And if you want, you can still use this in this notepad editor, and it will all be the same. Okay? I'm going to use this. And again, it's not my favorite, but a lot of people like it. That's why I'm going to use it. Okay. So when you save money for retirement, typically what you're going to do is put a little bit of money away every month. So our simulation is going to start with that basic fact. And since we don't need to predict whatever happened in the past, we're going to start with whatever parameters we have now. And so we're going to start really easy. And we're going to be using something in Python called the datetime package, datetime module. And so since we do our imports at the top of the screen, we're going to import normally what we import, which is always sys and os. Import sys os, and then under that we're going to import datetime, except that we're not going to do that because instead we're going to say from datetime, import date, comma, time delta. So what we've done here is we've just imported two of the items that we want to use that are in the datetime mod. And that way we don't have to import the entire datetime. It's a little bit of it's called leaner. It can make your thing run a little faster. Who cares, right? I don't care. But some people care, so this is what people do, and that's what I'm copying. Okay. I say copying. I built this program myself, which means that it will be terrible. But I'm not, whatever. Who cares? Do you care? You're here. You're still watching. Let's go. We have our datetime module and our sys and our os. And so what's going to be important? Well, we need to know today's date. So we'll start there. Today's underscore date equals date dot today, open close parentheses. All right. And I like to verify that things work, so we're just going to say print today's date. Now you see that this autocomplete thing showed up, and so that can sometimes be helpful to make sure that you don't misspell something. So, the first thing we're going to do before we get too deep in here is we're going to create a space to save all this stuff. So I'm going to, in my version, I have this up here. I've got this little icon. If I click on that, it allows me to change where I want to go. And I've made a folder called Python work. So now it's just C:python work. Okay? And so that's where I'm going to start my simulator. And if we can just line this all back up, that'll be great. Okay, so when I do that, I think that it may try to restart the console here. And I'm not sure. But we can say import os.get cwd, which means get current working directory. And it says I'm in C:// Python work. Okay, and that's where I want to be. That means that's where it's going to save anything I save. Over here, when we go to this, we might want to say file, save as, and we'll go to the same directory, Python work, and we'll save this as retirement underscore simulator.py. Okay. So now we have our retirement simulator.py. It's stored in our Python work directory, and we have our consoles running in our Python work directory. So we've gotten off to the right start. We know where all of our files are going to be stored and whatnot. So now if I dare to run this, it says our working directory is Python, and then it prints out today's date, which is 12/20/2021. So if you're watching this 100 years in the future, then this is actually the date that I recorded this simulator. All right. So what do we want to do? Well, we're going to imagine that we got paid today, and that we get paid with some regular pay frequency, like possibly semi-monthly or every 2 weeks, or it could be whatever you want. And I'll show you how to do that. We're going to use the time delta for that. And so we're going to just hard code in our pay frequency to start. Pay frequency equals time delta days equal 14. So this means we have a pay frequency of 2 days, or I'm sorry, 2 weeks. Now, we could do things another way, right? We could say 2 weeks equals time delta, same thing, days equals 14. We could say 1 year, not with a parenthesis, 1 underscore year equals time delta. It's gonna only work if you spell it right. Time delta days equals 365.25. And then now that we have 1 year established, we could say, how long is a month, right? A month isn't always 31 or 30 days or 28 days or whatever. We could just have an average month where we say, 1 month equals 1 year divided by 12, right? And if you get paid semi-monthly, you get paid every half a month, you might divide that by 2 further. So these are just ways to have a hard-coded reference to a time. And so since we did it this way, I'm going to cut this, and we're just going to pick a pay frequency of 2 weeks. So instead of having it like that twice, we're going to say our pay frequency is 2 weeks. I like to do this because I like my Python code to basically be commented in a way that doesn't even require comments, right? I don't have to say that our pay frequency is 2 weeks because I've made our variable pay frequency, and I've made the variable 2 weeks also pretty obvious as to what it is. So with that said, That's our pay frequency. Now, what do we want to do? Now we need to establish perhaps how much money we're going to put into our retirement account. Or maybe if we back up, we say, well, maybe we already have a retirement account and it has some money in it. So if you don't have a retirement account, you can just say 0. And if you do, you can put whatever number is actually in your account. We'll say amount already in retirement equals random amount. And I really am not a fan of some of these automatic completions, but so be it. All right, so we already have some amount in our retirement, and we can say now we want to move to how many. Well, we have this pay frequency, so we're assuming we get a paycheck with some frequency. So it may be helpful. It's going to end up being helpful to know how many paychecks do we get in a year. And so if I say paychecks _ per year. And so what that's going to end up being is we want to force it to be an integer. So we're going to start with int, and we're going to use a rounding scheme here to round to the nearest integer. And I'm not sure exactly why I do it like this, but this is how I do it. All right, so what do we want to do? We want to take a year. So we'll say we already described that, 1 year divided by pay frequency. And since we're rounding, we need to have a comma. We want to round it to the nearest integer, and then we force it to be an integer, and that's it. We have paychecks per year. Okay. So I'm going to add some extra space, put this up a little bit higher on the screen. All right, so we've chosen a pay frequency. Now you can see if we chose a 1 month pay frequency, we would be dividing 1 year by 1 year divided by 12, so we'd end up with the number 12, and that should be their pay frequency if you're paid every month. So we should be getting the right answer here. And if we're paid every 2 weeks, our pay frequency should be 26 paychecks in a year, in case you need to verify or check that out. All right, so now we need to determine an amount going into our retirement. So we'll call that add to retirement. And we'll just say $100 right now. We're going to put $100 in our retirement every paycheck. Hopefully we get paid enough so that's feasible. And so now we just need to pick a retirement date. And so the way our simulator will work is that we'll choose a date in the future that we want to quit and not be working anymore. And as we march through time, we'll be adding our paycheck, our contributions to the retirement account, and summing them all up. So we'll just I'll pick a date, retirement date equals, this is the format you need for a date time. You'd say date, and then it tells you year, month, and day are the 3 things you want to put in for a date. So we'll say 20, 30, 3, 31. All right, March 31st, 2020. You have to put in a real date, or it will be mad at you. So now that we have a retirement date, and we have, up here we have today's date. Here we can get rid of some of that extra space. I think we just need one last contrivance here, which is we have an amount already in retirement. So now we want to start with our retirement start amount. So we're just going to say retirement equals, and we'll do a copy and paste so that we don't have any mistakes. Retirement is equal to the amount already in retirement, right? That sort of makes sense. And now our simulation gets started. So we're going to use something called a while loop, and this basically continues to loop as long as the condition is not true. So while today's date is less than, while the while loop functions as long as the condition is true, regardless of what I've said previously. So we say while today's date is not equal to, is less than the retirement date. Then we want our retirement plus equals what we add to retirement. So we add to retirement what's currently in our retirement, and then after that we want to make sure we update today's date so that we skip time by a pay frequency. So we'll say, we'll copy that, today's date plus equals, and we need our pay frequency. And that is the very simplest version of what's going on. And so I started here because this is actually what happens, right? Time marches on, whether we want it to or not. And if you add money to your retirement via your pay frequency checks or whatever, then that's what you do. Now, you'll notice, if you're paying attention, that we didn't do anything about adding any interest. You know, this isn't an account bearing. This is basically like, putting money under the mattress. If you were putting, your cash under the mattress with this frequency, then this is how much money you'll have at the end of that time. So as we go on to the next sets of tutorials, we're going to add some complexity, including adding some of that interest, and then finally even more complexity, adding really realistic interest rates based on market returns, historical data. So, but we'll get there. We don't need to start there. So the last thing we might want to do is to just have a print statement that shows what we have put in our account, so that we can kind of verify. And so what we'll say is print, and we want this to be an F string. And so inside the F string, we want to write I have. We're going to do open close bracket, and inside that bracket, this is what the F string will put. We want to print our retirement. And I'm going to make it fancy enough that it doesn't print a floating point number with 1,000,000 decimal points. So we'll say :.2f, and that's just the way of doing these print statements, so that everything in there shows up with 2 decimal places. Okay, and then we'll say as of, and we'll print open closed thing, today's date, and that should be, we'll put a little period after that for fun. So today's date should be updating every time we run in the simulation, so that should be the final date. It should be some date after our retirement date, on or after our retirement date. So 3/31. Okay. 2030. All right. Well, that is all that we need for this. So we can save this, and then we can hit the play button here. All right. And we didn't have any errors, thankfully. So I have $31,600 as of 2030/4/1. So that's the day right after. How about that? Okay. And so we could verify, if we were so inclined, that there was in fact this many weeks or this many paychecks that we put $100 in. I want to go back and just say that we could have also done another approach where maybe we have a salary, annual salary, or we'll say current. How about that? Current salary. And our current salary is whatever it is. I hate this arithmetic error. I don't understand it. Current salary. And instead of adding a fixed $100, we maybe add a fraction of our salary. But of course, this is our annual salary. So this would be divided by the number of paychecks we get per year. And so we could say one paycheck is current salary divided by paychecks per year. Okay. And so that would be, before taxes and all that. But usually if you're using a percentage of your paycheck, it goes before taxes anyway. So then finally we could say add to retirement is equal to some fraction. Maybe it's 5%, maybe it's 10%, 0.10, 10% times one paycheck. All right. and then we would just you can make that comment so that we can be an option to activate later. But now if we add 10% of our paycheck to the retirement every pay period, we can see how things are different. So if I save that and I run it, now I've got 51,538 as of the same date. So yeah, we saved more money doing it that way. And so I think that I want to make sure that I've got all the same variable names and everywhere. Okay. So the last thing I want to do as a matter of course, just to convince you that everything is working the way that we expect it to, is to run what I'd call a verification. So to run a verification, we'll do the same thing here. I'm going to just copy and paste it in, but I'll go through it. So here our retirement amount is going to be $100 to start. It's going to print the word test so we can be sure that this is the test portion. And then we're just going to loop through the number of paychecks per year, which is, we have a slightly different name. We said it was paychecks per year. So I'm going to replace this with paychecks per year. And so then we will do this. We'll add $1 to our original amount, which is $100. And then we will print inside the loop, I have so many dollars in my retirement after number of paychecks per year, but really that is the number I after an I plus 1, if we're going to be real technical, since I starts with 0. So I have, and then we'll write paychecks. Oop. So I have so many dollars in my retirement after one paycheck, or how many paychecks. Okay, so we will we'll save and run that, and so it'll still should print the original amount, but underneath it it'll print the test. Okay, so there was the same amount as before, but now in the test, now we can see that we've added $1, $2, $3, and so on, up to $26 after 26 paychecks. And so the while loop works exactly as we expect. The retirement is adding $1. We started with 100. We should end up with 126 after 26 paychecks. We see that there's 26 paychecks per year, as we said that there should be. So everything checks out so far. So thank you for watching this tutorial, and hopefully you'll stick around for the next one, where we will add in some complexity by adding in some kind of just a fixed amount for the paychecks for interest. So again, what happens in reality behind the scenes, something after you've put your money in, your money gains or loses interest based on whatever investments your money is invested in. And sometimes that's in your control and sometimes it's not. And so we will pick just a kind of an average number and show how to turn that into, again, a verifiably correct number. And then we will eventually make simulations that will use historical data that we can borrow, we can randomly sample from the historical data to create a more realistic simulation. Finally, where we're going to go with this entire thing is we're going to kind of use a multiverse approach where we maybe do 10,000 simulations of 10,000 stock portfolios, and we'll see how they average. So, well, not two things, but how they average, and then how that compares to what you would call the ensemble of final results. So there will be a most common final result, and so the most common final result will likely be close to what our retirement result would look like if we have a realistic simulation of what's going on. So if you stuck around this long, good for you. And thanks for watching, and I hope that you will join me in the next one.